Hello, in this video, I would like to look at the Bayes rule together with you if you have questions. After this, we're going to look at the homework, okay? So the Bayes rule is very important, especially in the engineering department. It uses a lot because when you're going to see an example later in your homework. For example, if you sometimes you have like parts here, you have parts here and the parts here. So for each one, for example, you have the probability of this one is defective, the probability of this one defective, the probability of this one defective, the probability of this one is defective. So sometimes if a system is not working and the probability of each part is not working, they all have probabilities. Okay, so for example, the whole system is not working. Now, if you know from your previous experience, you know that the probability of this one is not working is 0.9. The probability this part is not working is 0.5. The probability this part is not working is 0.3. The probability this part is not working is 0.1. Now, if the system stops working, now you want to know which part you need to check first. So this is what we do on the or what's the probability that the system will be broken at some certain point. So that's the application of the Bayes rule. Okay. Now let's look at this section. You can read this total probability, this example. I would like to ask you to look at this picture first. So basically, this picture has an event A, but the event A has divided into different parts. Each part has a condition for the A happen. Okay. So now the probability A together equals the probability of equals 1 into K equals the probability of each one that the probability of B, I, the probability of B happened, and then given B happened, the probability of A. Okay, this is actually the combination of the conditional probability. Now let's look at the example. If a certain assembly plant that machines B1, B2, B3, and makes so B1 is 0.3%, 30% or 0.3, B2 makes 40%, 0.45, and B3 makes 25% of the product. Okay. Now, it is known that from the past experience, 2% from here is defective, and 3% from B2 is defective, and also 0.02 from B3 is defective. Now, suppose that a finished product is randomly selected. What's the probability that it's defective? Okay, so now we have product coming out. Now, what's the probability that the product is defective? So 30% from here, 22% is defective. 45% from here, 3% is defective. 25% from here, 2% is defective. So if a product is coming out, we're going to say is a defective. So we're going to say, okay, the probability of this product is defective. What's the probability? So probability from the B1, 30% from B1, and 0.02 is defective. And the plus, the second one is 45% chance from B2, but 3% is defective. Then add the 25% from B3 company or plant, and then 0.2% are defective. So you add all this together, it's going to be a product that's defective. Randomly selected is defective. Okay, so that's how you that's the meaning of that. It was how you apply this formula. Okay, look at next one. The Bayes rule actually is from the previous formula. You can have the Bayes rule for BR a given a condition that is from R. For example, and what is my previous page? I don't have it. From the previous example here, if a part, for example, if the part is selected and we find out that this part is defective. Now we want to know which plant it is from, or what's the probability that plant is from A, from B1, or that part is from B2, or that part is from B3. Okay, so if we find a part is defective, which plant it will be from, like the probability of that. That's the explanation of this probability. So if A represents the defective part, and BR represent that plant company number, and this equals PBR, and the probability that A given BR and divided by the total PBI and PA given BI. Well, when you look at the formula, it's very complicated. But if you look at the example, it's not that hard. And I will also give you explanation in one of your homework problems as well. For example, so with the reference of the previous example, if a product is randomly chosen and found to be defective, what's the probability that it was made by B3? So now the probability of B3 and the product is already defective. In the previous example, we know that our product from B3 and it is defective is 0.25, 25% from B3, and then the probability that it is defective is 2%. Well, the total, the product is defective from any of them. The probability of that is 0.3 times 0.02 plus 0.045 times 0.03 plus 0.25 times 0.02. So that's the total probability of a part select from the company, from 3 plants that is defective. And this is the probability that is defective and from B3. And if you divide that, that is the, given that part is defective and it was made by B3. Okay. Okay, that's that. Let's look at the next example. A manufacturing firm employs 3 analytical plans for the design and development of a particular product. For the cost reasons that all 3 are used at varying times. So part 1 used for 30%, and part 2 used for 20%, and part 3 used 50%. And the part 1 defective is 1% will be defective, 3% will be defective, and 2% will be defective. And now the question is, if a random product was observed and found to be defective, which plant was most likely to use and thus responsible? So first one, only 30%, we use 30%, and 1% defective. So you multiply them together, give you 0.01 times 0.3%, and it's going to give you 0.003. That's for the first one. The second one is 0.023 times 0.2, which is 0.006. The third one is 0.02 times 0.5, and it's 0.01. Okay. Well, this is the probability that it's defective is from plant 1. We'll have to divide it. If you don't have to divide it, compare that. Now it's very obvious that the third company is going to be responsible. It's very likely the third one. Even the second company has 3%, has a higher percent that the product is defective. Even if 3% is higher, but we don't use that. We don't use this one. We don't use the part 2, plant 2 that much. So plant 3, even that plant 3 only 2% chance that plan 3 will be defective. But we use plan 3 so much, 50%. So that we have the result, compare that and that and that. Wait. And we can tell that plan 3 has the biggest number, has the biggest probability. So it should be responsible for that. Okay. So if you want to find the probability of each one, you have to use this one divided by each. So first one is 0.03 divided by 0.06 plus 0.03003 plus 0.01. You find that it's going to be 0.158. 3 together will be equal 1. Okay, so this means, well, either one of them has to be, is from one of the 3. So for sure, one of them have a problem. Okay, so second one, you use the 0.006 divided by the total. Third one, use 0.01 divided by total. So that's the percentage of each one will be responsible, or the probability of one of them having problems. Okay, so that's the Bayes rule. And next, I'm going to record a video for your homework.